Welcome in, everyone. We are at the end of week 10. Gonna finish up a if statements. It's gonna be kind of a short day today, just because we're pretty much done with this 14 lesson, right? Lesson 14. We're pretty much done with this. If anything, all we need to do is finish up the rest of the lab, and then give some sneak peek hints on the next project. Now, the next project is really asking us to implement a decision tree, right, with subtrees inside of it. So just as a sneak peek into the next project, it's pretty much going to look like a decision tree that we showed a couple days ago. Right, so you can think of a decision tree as, we're branching off into different scenarios, and some scenarios can have subtrees, right, like smaller ones within another branch. And so this is pretty much what our project is going to ask us to implement. Right, so here we'll go on this in a bit, but I want to make sure that we can uh, implement if statements. All right, so here, let's open up the lab 14 and the lesson 14. Let's see where we're at. Okay, so let's see, lesson 14, and then lab 14. Okay, let's see where we're at. Okay, I know we did finish part one, so I want to collapse that. Let's see, part two, I asked folks to get this done at home. So I'm going to skip over most of these, and hopefully folks can do this at home. Okay. Let's see. Okay, we got to part three. Cool, cool. What else? What else? Okay, just let's do a warm up real quick before we finish the rest of the lesson. Right. So the warm up here is number one in part two. We were asked to implement four branches that tell us what generation we're in. So baby boomers, Generation X, millennials, Generation Z. Once again, if you're on the recording, please try it out yourself. Because if you're just going to copy down the solution, you're not going to get much out of it. It's actually going to ruin creativity. But here, let's do one approach. Right, one approach we can do are a series of if and else if statements that branch based off of the birth year. So this birth year is a variable that we defined all the way in the beginning. So I'm going to go back to the very top and play that cell. Okay, let me make sure the birth year is defined. So I'll run this, run this. Okay, cool, there it is. So I'm just going to run those two, meaning that we should be able to branch based off of those now. Right, so here, let's implement the first one, baby boomers. Right, so there's definitely going to be some condition, right? If some condition, then we're going to print baby boomers. So the condition here is that we're within this range, right? There are so many different ways we can represent this. One way we can do it is with 1946 less than or equal to birth year less than or equal to 1964. Right, you can do it this way. There's another way we can do it as well, but I'll talk about that in a bit. Okay, cool. And then we can just implement the other branches, right? Like Generation X. So Generation X would be the other condition, which is 1965 equal to birth year equal to 1980. All right, this is Generation X. Okay, and then I'm just going to copy this twice for the next ones. Okay. Then, okay, let me just change these numbers. So 1981, 1996, and then 1997, 2012. Okay, let me test this. So I'm going to run this real quick. I should be... Oh, I forgot to change these outputs. Millennials, Generation Z. Okay, there we go. So yeah, looks good. I'm born in 1996, so I guess I'm a millennial. Okay, cool. Let's see. This is just one way we can do this. So I encourage folks on the recording to try it out yourself before copying out the solution. Just because you kind of want to try it out and increase your kind of problem solving skills. Okay, so highly recommend not copying this down until you try it out. But anyways, another way we can do this is with a series of single conditions, right? Like technically, each of these conditions are checking two things, right? It's checking two intervals, but we can actually just represent this equivalently to this right here, right? So I'm just going to do the same exact thing, right? We can say something like if let's see, let me look at these real quick. Uh, hmm. Okay, you know what? I'm not going to go into the other way of doing it, but hopefully people might see that you can. Um, okay, you know what? I guess I'll show the other way of doing it. So, one other way we can is by kind of going opposite direction, right? Like we could write a single condition that checks if we're greater than 1997 or greater than 2012, whatever. Right, so here, let me start off with the 2012. Right, we can just check one single condition. Like we can say if birth year is greater than 2012. I forget what this one is. I'm not really familiar with these generations, but I think someone last class said this is generation alpha.
Generation Alpha.
Oh, okay, generation alpha. Cool. Yeah, thank you, George. Yeah, so we could take it the opposite way, right? If birth year is greater than 2012, print generation alpha, right? And then we can go ahead and check the previous years, right? Like we can use a else if here, right? So there's going to be some pretty cool stuff, right? We can say if birth year is greater than 1997, then print Gen Z. Okay, and let me do the other one, millennials. Greater than 1981, print millennial, and next is Generation X. Okay, birth year is greater than 1965. Print Generation X, and finally, baby boomers, 1946. Oh, I meant elif or else if. Then it's going to be baby boomers. Okay, let me just test this real quick. It should print millennials for me. Okay, sweet. So just to trace through this, right? My birth year is 1996. Is this true? No, it's not. So we're gonna check the next ones, right? Is this true? Right, 1996 is not greater. So yeah, this is false. So we're gonna cascade down. Right? Is this true? Yes. Yes, it is. So I'm gonna print out millennials, right? And it's not going to perform the rest of this. Right? If an earlier condition is true, then the next else ifs won't happen. So that's why it only prints out millennials. Okay, the reason why I'm reiterating that the future ones won't happen is if we disconnect this tree, into separate ones. Right? Technically, this is one single tree with 5 branches, right? But we can actually disconnect this into multiple trees. Right? So if I change them all into if statements instead of elifs, right? The tree is technically disconnected now. So we have 5 different trees. So what do you think is going to happen? Right, let's say birth year is 1996. Right, let's say birth year is 1996. Let's kind of see what's going to happen. Right, is this here? I'm just going to press play. So I'll press play. Okay, you kind of see what happened here. It printed 3 different statements. Right, you see the importance of connecting trees and disconnecting. Right here, we disconnected it, so every single condition is being checked. Right, like this is true for me. 1996 is greater than this, so this is true, and then this is true and this is true. Right, so everything's being checked. But once again, if we connect them with the else ifs, right? So I'm just going to undo all of these. Right, I just connected them. This means that this earlier one won, so the next ones won't happen. Right, so it's kind of important to understand the difference between else ifs and then separate if statements. Okay, hopefully people found this helpful. So yeah, that was part 2, a little warm up into this. There are a couple other parts here too, like number 2 and then number 3. I help folks get started off on this, so I'm not going to do this in class. If folks can try it out at home and submit it, that'll be great. It'll be good practice. Okay. I'm going to move down to, let's see, part. We actually have enough to get part 3 done in the lab, but I figured we should probably get the what's it called? Lesson. All right, let's finish up the rest of the lesson. We only have like a tiny portion of it left. So I just switched back to the lesson notebook. We got all the way down to the bottom where we were going to do some logic. Right, logic, you can think of this as a Boolean algebra. For folks who might have heard of logic gates, you might have heard of something called ands and ors. Right, so let's talk about the difference between these operations. Right, these are Boolean operations which allow us to return true or false. So I'm just going to load up a terminal real quick and kind of show some Boolean operations. Right, like there is an operator called OR. Right, basically OR is kind of like a plus sign. It's kind of like saying if we said true or false, or actually I'm going to say false or false. Right, we have 2 booleans right, on both sides. Right, this is kind of like saying, are any of them true? Right, and it is false. Right, with an or, both sides. I mean, one side has to be true in order for the whole thing to be true. So this is a whole condition. Right, so if we do like a false or true. Right, once again, with an or, only one side has to be true. So this gives us true. Right, and then same with true or false. Right, the left side is true, so the whole thing is true. And what about true or true? True or true? this is true, right? Because one of the sides are true. Okay, let's make this a little more concrete, right? This might seem kind of weird. Maybe I could use some numbers, right? Like, let me just create a variable. Age is equal to 29. Right? It doesn't matter. So I'm just going to create a variable. Let's just make up some random conditions, right? I'm just going to say age is greater than 21, or age is greater than 60. I'm just gonna make up a number. Okay, so is this whole thing gonna be true or false? Right, so there are two sides. Right? The left side is one single condition, which returns a boolean, and then the right side is another condition. Right, so is this true or false? Yeah, so is the left side true? Alligator thing? Oh, so this reads super what? Oh yeah, you're good. Yeah, if anything, this just reads age is greater than 21. Right, so yeah, yeah, so true or this is yeah, exactly. This is false, right? So this is gonna true or false. What's the true or false? Only one side has to be true, so this whole condition is true. Yeah, hopefully that makes sense. Let's do a different one. Let's see, age is greater than 21. Um, let me just make up a number. Age is greater than 30, or age is greater than 60. Right, I'm just making up some random conditions. This is yeah, it's false, right? Because both of these conditions are false. So yeah, false. Cool. Hopefully, people are getting a sense of the logic. Right? Let's talk about another operation called the and. Right? The and means both sides have to be true in order for the whole thing to be true. Right? For example, false and false is false. Right? False and true, right, is still false because both sides need to be true. Right? And then true and false, this is false. But finally, if both sides are true, then it is true. Right? So here, let's make this more concrete again. Right? Once again, our age, right? Our age is 29. So let me just make up a random condition that consists of an and. So I'm going to say, let me see, what is the range for a president? How old do you gotta be for president? I'm gonna look this up. Age limit for president. There's like a bottom limit and an upper limit. Oh no, there is no upper limit. Okay, I thought there was. So yeah, requires president to be 35 or older. There has never been an upper one. Interesting. Okay. Yeah. Okay, there is a lower limit. I'm trying to think of something that has both a lower and an upper. Yeah. Yeah, let's see. Is there something that has an upper limit? Huh. Hmm. Okay, you know what? What about let's just represent like teenage years. High school sport? Yeah. Mhm. Okay. Yeah, okay. Yeah, we could do that then. Yeah, here. Make a we can make a condition that represents if you can be in a high school sport. Right, so how do we represent that with an and? Left side. So we could say age is I think you said 14, right? So you could say if you're 14 or greater, right? And what's the other limit? Yeah. So age is less than or equal to 18. Right. This condition represents whether or not we can. Right. This is false. Remember why it's false? It's false because our age. All right, let me just print this again. Age is 29. All right, so is this true? Yeah, this is true. Is this true? No, it's not. So the whole thing is false. All right, let's. Yeah. Yeah, yeah. hmm Yeah, exactly. Yeah, true and true gives true. So if I change the age to something else, like here, let me just reassign age to like 17. All right, so there we go. I just reassigned age and rerun this condition. It should give us true now. Both sides are finally true. All right. Cool. Hopefully people are kind of getting a sense of ors and ands. Okay, there we go. So that's ors and ands. Let's see. Oh, I just did all of this in the terminal. So folks can try this out later. It's just saying, oh, what happens if you do false and false? Hopefully folks knew what this is going to do. Yeah, false, right? Both sides got to be true. Okay. All right, I think we're actually done with this. We're done with the notebook. Lesson 14, we're done with it. So let's move on to the lab. We should have enough to get the part 3 done. Part 3 is asking us to do a few different functions. So let me just skim this real quick to see where we're at. Boom, boom, boom. Okay. Oh, that's a lot of them. 4 different functions. Grade, letter, percent. Interesting. I'll help folks get started on the first couple, and then you can take the rest home. So I'll help folks get started on number 1 in part 3, and then number 2 as well. All right, just so folks can get started on writing a function. And then number 3 and 4 are a little harder, but you should be able to get it done if we do 1 and 2 together. All right, let's see. Let's write some functions that consist of outcomes. Number 1 here is asking us to convert our previous 2.1 right, to a function. Right, so earlier we did some generations stuff here, like here, right? So we were converting a birth year into pretty much a string, right? We're branching off the year and then giving some sort of generation. So we're pretty much going to use this somehow, right? Let me go ahead and copy this. We pretty much need to write a function that encapsulates. Okay. So I'm not even going to paste it. Right? It might be better to not paste it. So we want to write a function here called getGeneration, which converts a number into a string. Now that's what it's asking us to do. So, say we have a imaginary cell. Right? I'm just gonna pretend like we did implement this already. Basically, if we were to invoke that imaginary function, right, get generation, and I'm just gonna hard code a year here, right? Like 2000. Right? But basically, if I print this, I'm just gonna wrap this in. Right? It should print whatever 2000 gives us in. I forgot what 2000 is. Probably millennial. So this should probably print millennial. I think. Here, let me double check. 2000 in millennial. Oh, no, it's not. Gen Z. Okay. Should be Gen Z. My bad. Okay, so this should print Gen Z. All right, and let's say we call the function again, like get generation, say 2000 and let me say 1995. This one should print millennial. Right, and just some other stuff. Hopefully people are seeing the goal of this function, which doesn't exist yet. All right, so get generation. Let me just put another one, like 1972. We'll go 1970. This is my dad's year. Let me see what 1970 is supposed to print. 1970 Gen X. Okay. Scroll down. Print Gen X. Okay. Cool. So yeah, do people kind of see the goal of this function? Right, it's to take a number and return a string. Okay. So I'll help folks get started on this. Define a get generation. Right, and then it does take a integer as an input. Right, I'm just going to call it year, and that's what it asks us here to do, anyways. Okay, get generation year, and it needs to return something. Right, so you know what? I'm actually going to leave it half complete because I want folks to try it out themselves. Okay, so I'm just going to return not implemented. Not implemented. Or I'm just going to put IDK just so folks kind of see. Okay, so I'm going to run this and then press play here. Okay, cool. It's printing IDK 3 times. Right, hopefully people kind of see what to do. This function should branch off into different scenarios. Right? It's going to use this year argument, branch off into different scenarios, and return something else. Right, so please try this out yourself. I'm going to give this as a to-do. Right, once again, all you need to do is implement like 4 if statements, 4 or 5 if statements, and each of them return a different string. Right, so try that out. To do. Okay. Let's see. Okay, let's move on to number 2, and then we'll take a 15-minute intermission so folks can try out the rest of these. Okay, let's see. Compute letter grade. This one is asking us to convert a float, right, a grade percentage, into a letter, right? Like, let's say, let me make a new cell and pretend we're calling it. Okay, so say we were to call the function grade letter percent. Right, I'm just going to put in a percent score here. I'm just going to hard code a random number like 95. Right, this should print A. Right, because 95 is an A. Oh, actually, it didn't print yet. Let me wrap this in a print statement. It should print A. Right, hopefully people see that this function should return a single string. Okay, and then let me just do another one. A grade letter percent. Let's do another one. Let's go 85, 87. And then this does return a string, so I'm going to print it. Print it. This should print a B. All right, and so on. Okay, hopefully people can kind of make your own test cases. All right, there's A, B, C, D, and an F. So yeah, go ahead and get the rest of these in. So let me start this function up. Right, give folks a little starter. So a function called grade letter percent. Okay, it takes a percent, we'll call it this. Okay, and then it does return something. Right, I'm just gonna return NA for now. Okay, so folks can do this as a to-do later. Right, you might want to put the doc string in here as well, but yeah, you don't have to. On the exams, you should though. Okay, so to-do. So let me just run this function. Zoom in a tiny bit. So press play. Then press play here. Okay, cool. It says NANA. All right, I'm just leaving it as unimplemented so folks can get this done in a bit. All right. Let's see. Okay, and then one more. I hope folks get started. There's one more, and you can fill it in at home. Okay. This next one is improved letter grade. It wants us to pretty much do the same as here, but with an additional argument. It's pretty much saying that there's going to be two arguments, right? A numerator and a denominator. So if we got like the numerator would be our score, and then the denominator would be the total points. So this is pretty much saying, here, let me make a new cell, right? Make a new cell. Like pretend we're calling this function grade a letter. It takes two arguments, right? The numerator and denominator. So let's say you got like a 40, and then the total amounts of point was 50. All right. If you got a 40 out of 50, this should return a B. Right? It should return a B, and then we should print that. So this returns or prints a B. All right, so people kind of seeing why, right? 40 out of 50 is a B. Okay. Hopefully people kind of see why, because 40 divided by 50 gives you, I think, 80%. Okay, and then let's do another one. Grade letter. Let's do like a different number. Let's go like 6. Let's go 6 and an 8. All right. Well, what happens if you get a 6 out of 8? What's the what should it return? It's just some math, right? This simplifies down to 3 divided by 4. Yeah, it's like a 75%. So this should print. This should return a C. So if we were able to print it, this should prints a C. So yeah, hopefully people kind of see what this function is doing. I hope you get started on it. Grade letter. All right, there are two arguments here. One is called score points, and then one is called total points. All right, so basically, you're gonna have to do some math with this. You pretty much have to divide these two, and then branch based off of that division. Okay, I'm just gonna return a dummy statement for now. I'm just gonna return NA. All right, not available. So there we go. Prints NA. Cool. And folks should be able to get this done. To do. Okay. Okay. Let's see. Okay, cool. That should give folks a good head start. You can get the last part done at home. But here, let's try it out. Let's take a 15-minute intermission and see if folks need any help on any of these questions. All right. Once again, we're working on part 3. I gave folks a starter on number 1, number 2, and then number 3. All right. So yeah, let's give it a shot here. And if you're on a recording, please try it out yourself. All right. I'm going to pause the recording here. Do part 3. Okay, welcome back, everyone. We are back from intermission. Let's see. Hopefully, people got a chance to try these out. These should be some good ones. So, yep. Oh, okay. Yeah. Okay. You know what? I'm gonna let folks try this out at home, so we can get to some project hints. Right? I know folks might be like, "Oh, just go through the answer," but no, I'm not gonna go through this answer. I want folks to try it out themselves, and kind of like problem solve how to solve it. So yeah, please try those out at home. If you have any questions, feel free to post in the discussions. Right? It's okay to post code in the discussions for these labs, right? But part three, yeah, try it out yourself. Okay, let's see. Let's move on to the homework hints, and we'll be done for today. All right. So this assignment is called Calculator. It's going to ask us to implement some operations for a widget. All right, so here, let me download it. Okay. You know what? I already downloaded it. It's right here somewhere. So go ahead and download it, and folks should be able to open it right here. Okay, there we go. All right. Let me give folks a minute to download this to their notebook, to their server, I mean. Oh, for folks on Zoom, I was muted. Anyways, I'm gonna, yeah, for folks on Zoom, all I really said was folks should get the rest of the lab done at home. So, let's see, yeah, part three. If you can get that done at home, that would be great. And if you have any questions on how to solve it, please post it in the discussions. I'd be happy to help out with any of these. All right. But yeah, we're moving on to the calculator. The this project number something. Let me see. Yeah, project week 10. So yeah, go ahead and load it back up or download it. So it should be called the calculator. All right. Okay, for folks on the recording, I'm just gonna wait for folks to download this. All right. Let's get a sneak peek into this project. This project is asking us to write a function that calculates things. Um, it might be a little hard to see right now, but there is a widget here which I'm going to ignore for now. All right, let's go over the function that we're asked to write. All right, so we're pretty much going to write a function that simulates operations on a calculator. Right? In particular, the plus sign, the minus, the multiplication, division, and then a couple other Boolean operations. That's pretty much what we're going to do. So this will make sense in just a bit. It might seem like there's a lot happening. We need to write a function called doCalc that takes 5 arguments. Right? It's pretty much 3 arguments. Right? We have like a left side, and then a right side, and then the operation. Right? So this is kind of like saying we're gonna do an operation on 2 different values. So let's kind of let me pretend I'm calling the function, and this will kind of make it more concrete on what we're trying to do. All right, so let's say, let me make a playground cell. Right. For folks on the recording, I highly recommend reading through these instructions, because I kind of just skipped over it because I'm hoping folks will just kind of skim through it. Once you're all skimmed through it, go ahead and make this playground cell. Pretend like we're calling the function, right? Like let's say we go do calc. Right. Once again, it does take 5 arguments. Right. So here I'm gonna explain what those 5 arguments are. right? It's pretty much like two numbers in an operation, right? Like let's say we wanted to represent 1 plus 1 as an integer, right? So if I were to pass in 1 and then say this is an integer, right? And then pass in another 1, and then actually no, let me pass in a 2, 1 plus 2, and say this is an integer, and then do a plus operation. All right, once again, you might be wondering why these are all strings. It's just the way that the function was designed. Right? This function is designed to take only strings. You can see that in the docstring up here. Right? All of these arguments are strings. Okay. So this is saying, what is 1 plus 2 as an integer? Right? It's saying number 1 is an integer, number 2 is an integer. Right? What should it return? Right? This should, if we were to store this result, right? So this does return some value, right? So let me scroll up a bit. Do calc, it should return the result of the operation, right? Meaning that we can capture it. So I'm just going to store it in this result variable. Right? If I were to print out this result, playground cell, right? This should print 3. Right, so people kind of see what's happening. Once again, I'm making a playground cell that tests manually. This is a playground cell that manually tests our function. Okay. Okay, let's do another imaginary call. Right? Like let's say we were to do another calculation. Let's say we were to do another calculation, the same exact one, right? Let me go 1 and 2, but let's treat them as strings. So if I were to do 1 and then say, hey, 1 is a string, right? And then go 2 and say that 2 is a string, right? And do the plus operation, right? This should yield a different number. Right? Basically, when we're doing string addition, it doesn't really do math on numbers. It does something called concatenation. So if we were to print this out, right, let me just rewrite the result variable. Print result. What should this print? If we treat 1 as a string and 2 as a string and add them together, right, what should it give us? What should it print? Yeah, it should print the sum of 2 strings, right? So pretty much I'm asking, we're treating 1 as a string and we're treating 2 as a string. So it's pretty much saying what is 1 as a string plus 2 as a string. It's 12. All right, so hopefully people see that this should print a 12, right? Because the function is kind of specifying these a and b values. Right. Okay, so hopefully people kind of see the point of this. And these are just manually testing our function. Right, we don't have this do calculator function written yet. But here, let me go back up and kind of read over the instructions again. Right, so once again, we're writing a function called do calc. The first argument represents the value that we're working with, right? The a, and then the a type. This is representing the how to treat the variable, right? And b is the right side of the operand, right? And b type. This is how it's the type of it, right? Like it'll define what type of operation to do. And then same with this one, the last one. This is another operation. This is like saying, are we doing a plus? Are we doing a multiplication? Are we doing a minus? Right. So those are our 5 arguments. Right, so that's kind of what we see down here. Right, the do calc, there are 5 arguments here. Right. This is the A. Right, this is the A type. Here's B. And here's a B type. And this is the operation. Right, so we're doing A plus B. And we're treating both sides as integers. And in here, this is different, right? This is This is 1 plus 2, but we're treating both of them as strings. Okay, so let's pretend like we have this function. I mean, let's start this function up. Right, so we do need to define a function called doCalc, right? Because this gives us doCalc not defined. Right, let's go ahead and define it. So up here, we're going to go ahead and define a doCalc. Right. And it's going to take in 5 arguments. So you can take a look, you can scroll up and kind of see what's going on. Right, we got A type, B type operation. Right, they're all strings. So I'm going to get those in. Right, so I'll call this A type, B type, and then the operation. Okay. Cool. So let's go ahead and I'm just going to do a doc string so folks kind of see what it's doing. All right, so the doc string here, let's see, what's the purpose of this? It pretty much simulates operations on 2 values. So that's pretty much what it's doing. Simulates operations on 2 values. That's pretty much what it's doing, right? A operation B. Okay, so that's pretty brief. Let's see. The arguments. You can put the arguments in here. I'm actually going to leave it blank for now because folks can just do that at home later. But yeah, if folks want to get the rest of this doc string all done, then you should be able to fill it in. I'm going to keep it very brief. Right, it simulates operations on 2 values. Yeah, I'm going to keep it brief. Let's see, what else can I describe it as, though? Okay. Yeah. I'm trying to describe this a little better. This is pretty concise. Simulates operations on 2 values. Okay, I'll make it a little more detailed. A and B. Right, so the 2 values are A and B, and we're given the operation. Given an operation and certain types. That's pretty much the goal of this. Right. And folks can get in the arguments and the return value. Okay, so here, I'll just put in the arguments here. So arguments, I'll let folks do this at home. To do, folks can fill that in. And then returns, it returns the result of the operation. Okay. Cool, so there we go. There's a doc string. Let me press play real quick. Oh, you know what? Let me return a dummy value to make sure things are flowing fine. Right, so I'm just going to return a dummy string, right? Meaning it's just like, it's just to get things started. I'm gonna return like not implemented, right? Not implemented. So let me press play here to load the function in. Okay, this is like saying return NA, right? Not available. Okay, so return not implemented. And let me test these out. Right, so let me comment this second function invocation to keep things a little more simple. Right, so I'll comment that out. Let's focus on this first one right here. Right, so we're going to call the function doCalc. We're asking the function to do 1 plus 2 as integers. Right, so it should return 3, right? But it's going to return not implemented, right? Which makes sense because the function is hard-coded to return a string, right? So this evaluates to a string, right? Result becomes not implemented. So then we're going to print that. All right, so here let's let's kind of talk about what we need to do. Hopefully people kind of see some branches, right? Do people kind of see how we're going to branch into different areas with a calculator, right? Like a calculator has multiple functionalities. It's got like a plus, minus, multiplication, right, divide. Um, I don't think folks have seen this in the other calculators, but we're going to be implementing some Boolean operations as well. Right? These Boolean operations return a true or false. Right? It's not going to give us a number. Okay, so let's see. Okay. So here, I drew a picture earlier. I drew it in like 5 minutes, so it's going to be a little ugly. But I drew a picture earlier that kind of represents the decision tree of our calculator. Pretty much, the calculator will branch off into different operations, right? Like if we pass in the operator plus, we're going to go here, right? And then go into another subtree, right? The subtree is going to say, hey, are we doing integer division? Right? Are we doing float addition? Oh, I meant addition. Or are we doing string? Right? So you kind of see how there's trees. Like with the plus operator, there are multiple types of pluses we can do. Right? And it's same with a same with these other operators. Right? For the subtraction one, there's no such thing as a string minus a string, so you won't have to worry about that. All right, so here, let me just edit this real quick. Damn, I did run out of space. Here, let me edit this tree. Okay. I'm on a touchpad right now. Let's see how fast I can do this. Okay. So there are operations with a minus sign. Right? Basically, with a minus sign, the really only operations are with numbers. Right? It doesn't make sense to subtract a string from a string, and plus that doesn't even exist. Right? Like if I did hello minus world, right? This is an unsupported operation, so this is impossible. Right? But we can do numbers, right? Like 5 minus 4, right? We can do numbers. Oh, whoops! I have a space. There we go. 5 minus 4 is 1. Okay, there we go. Yeah, we can do numbers. So basically, with this subtree, there's going to be 2 branches. Right? There's going to be a tree for some sort of numbers. Right? And then I'll let folks think about it, but it's pretty much going to be float. Right? Pretty much going to be float, or there's some other ones too. All right, so go ahead and think about it. Basically, I'm saying that this subtree is not finished. So I'm gonna say dot 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 here. Oh, dot dot dot. Okay. Let's talk about the multiplication operator. Right? There are multiple things that are supported here, like numbers. Right? You might remember that we can multiply numbers like 5 times 4. Right? This is multiplying 2 numbers. You might also remember that we can multiply a string with a number. Right? Like if I did hello, right, multiplied by an integer, right, 4, this gives us hello, hello, hello. Right? And then I think it does the same both ways. Right? There we go. Yeah, same thing. Right? So we've seen those two, right? Numbers and then numbers and strings. Right? But once again, we can't do strings and strings. Right? We can't multiply hello with another string. Right? This is an unsupported operation. So let's go ahead and do those cases. Right? With the multiplication, we've seen numbers. Right? We've seen let me see. We've seen like integers, right? But you can definitely multiply two integers together, right? And we can also multiply floats together, right? So we can also do this. Add a line. All right, what else can we do? You might have seen that we can also multiply a string with a with an integer. Right, so boom, there is this right here. So we can multiply a string with an integer, which pretty much just repeats the string. Right, and you can do vice versa as well, right? Like the int and then string. All right, so once again, this tree isn't really complete. So I'm just gonna put a dot 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 here. This is a totally incomplete tree. Put a dot 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 here. Yeah, there's a lot of cases. Basically, I'm saying that this tree doesn't have full coverage. But yeah, did people kind of see the goal of this calculator, right? Like with a plus sign, we can have multiple, right? The A plus B can be different types, right? Like we saw that over here in the imaginary test cell. Right? See in this imaginary test cell, I'm saying that with a plus operation, right, we can do plus with numbers or strings. Right? Those are two different ways. So that's why we saw on this left side of the tree, right, there are multiple types of pluses. So here, I'll help folks get started on a couple of these subtrees, and it should get you a nice speed boost. We're going to implement the plus operator, right? So we're going to have to do a tree of branches. Okay, so let's work on the plus sign. Okay, the operator is a string that gets passed into this argument, right? We need to branch off of that operator, right? So there's going to be some big if statements here, right? We're going to check, we're going to branch based off the operator, right? If op is equal to a plus sign, right? If op is equal to plus sign, we're going to need to branch into different scenarios, right? Like we need to check if the type is an int, right? We need to check if it's a string, right? And depending on what they are, we're going to treat them differently. All right, so let's. Everything is passed in as a string, by the way. Right? These default are passed in as a string, and you see that down here. Right? You see how I wrapped one as a string. So we can actually let's work with the integer first. Okay, so this might look a little weird. Right? We're going to have some if statements within if statements. Right? The reason why is it's because it's going to be like this right here. Right? So here, let me show you the overall skeleton of what this might look like. Right? So it's going to look like. Let me see. But before you type this, it's going to be like do something. It's going to be like a subtree here. Subtree here. Right, and then there's going to be another operation, right? So we could say, oops, I don't know what's up with the indents. So equals to minus. Then there's going to be another subtree, right? And then for the other operations, right? But these subtrees are going to be nested. So this is going to be like if something, else if something, right? Else if something. So hopefully people kind of see the goal of this. The indents do matter, but yeah, it's going to look a little weird. I do want to say that we got to make sure our indents are correct, right? So here, let's say if the operation was equal to plus, we're going to need to check the types, right? Like are we going to do number? Are we going to work with strings? And so if we're working with numbers, right? Let's start simple. Let's say they are both integers, right? So let's say if the A type is equal to an integer, right? And we could say and A type, B type is equal to an integer. Right? Once again, the indents do matter because this is within here. All right, so I just implemented a branch. It pretty much represents this over here. Right? If we're inside the plus and then a subtree, if they're both integers, right, we need to treat them a little specially. Right? We can't just return them added together. Right? So this will handle this case right here. Here, let me comment this bottom out. So we're handling this case when both types are integers. Right? So, we could just return a plus b, right? Like a is 1 and then b is 2, right? Let's try that, right? Like let's go return a plus b. Now let's see what happens. So I'm going to press play here. So run this, and then finally we can run it here. Okay, I just ran this testing cell, right? It should have printed 3, but it's printing 12. Right? Hopefully people kind of see the reason why. The reason, these are strings. They are default strings. So when we pass it up into A and B, right, we're doing concatenation down here instead of addition. So we need to convert these into our relevant types, right? Like if we're treating A and B as an integer, we should probably convert them. Right? If we don't convert them, it's going to do some concatenation, right, which is different from addition. So the notebook does give hints on how to convert. Right? You can pretty much reassign the variable and convert it with the type and with the parentheses here. Right? So if I wanted to convert it to an integer, right, I can just say within this branch, right, a is equal to integer a. Right? So this is converting. Right? The right side gets converted to an integer, and then we're overriding a. We need to convert b as well. All right, cool. There we go. So we can test this. Press play, and then now I'm going to replay this playground cell. It finally prints 3. Right? Earlier it was printing 1, 2. So people kind of see what's happening here. Okay, so we just implemented this left tree right here. Right? Maybe folks might want to do this float tree later. Right? So I'm going to leave this as to do, but I'm going to skip over to this strings over here. Like, what if we're adding 2 strings? So let me uncomment this over here. Right? This one was meant to add 2 strings. It should print 1, 2. Right? But it's going to print not implemented. Right? People kind of see why it's printing not implemented. Right? It's because we didn't make a case for the string yet. Right? So this string is a subtree. A branch within this plus operator. So we could implement in here. Right? Like we could say else if. Right? Else if they're both strings. Right? You can do else ifs. You can do ifs. It doesn't matter. But I would use an else if. It's a little more efficient. So we could check that they're both strings. Right. So then, if they're both strings, we actually don't have to do anything. We don't have to do any conversions because these A and B are already default passed in as strings. So we can just return it here. We can just return A plus B. All right, so here, let's test this. So let me press play and then press play here. Okay, there we go. Yeah, now it finally prints 1, 2. Okay. Okay, cool. So this might look a little weird right now, right? Things are kind of indented and indented again. But the reason why is because there's some nesting in here, right? Like, let's say we were to move on to a different big branch, like this. Let's talk about this operator multiplication. Yeah, I'm going to skip this minus sign. Folks can do this at home later. Right? But for the multiplication one, this is going to be a big branch, right? So this is going to be uh, in a different layer of indent. Right? So some people might do it here. This is a pitfall here. Don't type this yet. Right? So some people might do the multiplication here. They might say, oh, if operator is equal to multiplication sign, then do something. Right? This is actually the incorrect indent because this is saying that it's pretty much taking this tree right here. Right? It's let me just highlight these. Oh man, how do you highlight here? Select. Okay, it's pretty much doing something like this. If we were to put that indent there, it's pretty much gonna go like. What's my line? Okay, it's pretty much. We can drag this. Let me delete this. Okay, so if I were to move the indents here, right? Like you see how if operation equals multiplication, right? The indent is within this big branch, right? This is a very pitfall, right? It's a very common pitfall because it's technically representing this tree, which is impossible, right? This subtree is impossible to get to. People kind of see why, right? If the operator was plus, right, it's going to enter here, right? The operator is never, it's not going to be this. So be careful with your indents, right? This operator meant to be on an outer layer, right? So I'm going to unindent that and maybe make it an else if, so they're kind of connected. Right, so I just moved it back one indent, meaning that the tree now looks like this right here, right? It's on the outer layer instead of inside. Okay, um, I know folks might be getting tired of me kind of repeating that same thing, but it's a very big takeaway because in previous semesters, people would mess up their indents and then they would have the incorrect decision tree. So hopefully this is a good visualization of the indents. Pretty much every subtree is indented another layer. All right. So if the operator is equal to a multiplication, there are multiple decisions to be made here, right? Like we can multiply integers. We can do string and integer. We can do integer and string. All right. So let's just do the easiest one first. Integers, right? So we could say within that, if the A type is equal to an integer and B type equal to an integer, then maybe we could do some multiplication. Right? Once again, we can't just return A times B because these are default strings. Right? So a string times a string would be some error message. Right? Like here, let me manually invoke it. Right? Let me make another case and do it with a multiplication. Right? So let me do a do calc. Let's say we were to do like 2 times 3. Right? So 2, and then treat this as an integer. And let's go 3, treat this as an integer. And then let's say we're trying to do multiplication. A result. Okay. And this should print. This should print 6, right? Because 2 times 3 as an integer is 6. Right, but let's see what it's going to do. So I'll press play. Oh, I need to run this top cell up here first. Okay. And then now I can run this one. Press play here. Okay, it did print 3 and 1, 2. from these first two print statements. Right? But then this third one had an error. Right? So let's see this third one. Okay, this third one, let's see. It's saying can't multiply sequence of type string. Right? So yeah, that's what I was saying earlier. Right? It's an unsupported operation. Right? So 2 and 3, these are default strings. So this is technically doing a string times string. So you might want to convert them to an integer first. Right? So a is equal to int a, and b is equal to int b. And that should properly convert them. So I'm going to go ahead and play this cell. And then now we can test it. Let's see. Okay. Yeah, there we go. It finally prints out 6. Right, because we converted the strings to an integer. Okay, let me do one more. Let me let's work on this branch over here. I'm kind of skipping over a bunch of these sub branches, but I'll let folks fill in the fully covered tree later. Right here, let's work with strings and integers. It is possible to multiply strings and integers. Right? Remember earlier we did something like a string times an integer, right? And we can do the opposite way, right? 3 times hello. Right? Yeah, we can totally implement this operation. Right? So let's pretend that we're calling it. Right? Like let's say I just invoke the function again. Do calc. Let's go like hello, and then treat this as a string. And let's say I do 3, treat this as an integer, and then multiplication. Right? This should return a string, right? Because the operation is a string times an integer. Okay, so if we store this result and print it, this should print hello, hello, hello. Kind of see what's going on here. So this is, if I press play on this, it's currently going to give us not implemented, right? The fourth one is not implemented yet because we didn't have a case for string and integer. So let's go ahead and do that. Right, this is a branch within the multiplication operator. So we can just implement it here, right? We can say if one is a string and one is a integer, right? And b type is equal to integer, then we can do this multiplication, right? So once again, the a is default a string already, right? But the b, we need to convert it to an integer, right? So we could do it here, right? We could say b is equal to int b, right? Because we only need to convert this one, and we can go ahead and return a times b. Right? People kind of see what's happening. So this is saying return the string times the integer. All right, so let's go ahead and test this. Okay, so I just press play. So let's test it. Press play here. Cool. It finally prints hello, hello, hello. All right. Hopefully people are kind of getting the idea of this assignment. I did show kind of a naive way. There is a cleaner way on implementing this. There's a way cleaner way. If folks kind of want to think about it and on how to simplify this code, there is a way. Pretty much one way to simplify is, I'm not going to give it away. But yeah, hopefully people kind of visualize this tree right here. Right here, let me put them side by side. Right, so all of these indents, right? So we did the plus over here. Right, we covered this branch over here. We covered the string. We didn't do the float yet, so folks can get that done later. And then we also did the multiplication over here. Right, we did multiplication with integer, and also this string int. Right, so that's all we did so far. There are multiple branches to do. So this is a playground cell that manually tests our function. There, a widget is down below. All right, all the widget does is create some text boxes that we can type things in. Right, it's just going to call the function for us. Right, so if you want to kind of automate this manual invocation, right, this widget will do it for you. So let me run this widget. Okay, there we go. Right, so there's our widget. Right, currently it's returning not implemented. Right, but we can test some values that we've already implemented. Right, like we did implement the branch for both integers being added. Right, so if I do both integers being added, right, so this is pretty much, let me go 1 and 2. 1 and 2, there we go. Right, so these widgets just control the arguments that are passed into the function. Right, so once again, this is really just doing these two lines right here, right? It's passing one integer to integer plus, right? That's what the widget is doing. So that's why it returns 3 here, right? And we change them to a string, right? Let me change both of them to a string. So A type is string and B type is string. Right? See how it returns 1, 2, right? This is really just doing this second one, right? The second one doing 1 plus 2 as a string. Right? So hopefully people kind of see what the widget is doing. It's just repeating this for us, right? It's wrapping it, so we don't have to manually type everything. Okay. So yeah, hopefully people kind of see what to do here. This is kind of a bigger assignment, and you can use the auto grading stuff down here. Right? There is an auto grading cell here, which will tell you what branches you're missing. Right? So there's people can run this later. You don't have to really implement every single branch, but make sure you run this auto grader, and it'll kind of tell you what you're missing. Right? Like right now, I'm missing a bunch of things. I'm missing a bunch. I'm missing integer subtraction, float addition. Right? I'm missing Boolean operations too. Right? Boolean operations are these ones. These equals equals, less than. I'm missing those as well. So, yeah, hopefully that gives folks a good head start. Is functions, is what? Yours doesn't run? Okay, I'll take a look at yours in a bit. Why doesn't yours run? Everything's blacked out? Okay, let me take a look at it in a bit. Oh yeah, I'm gonna end class in a few minutes. So let me take out I'll do debugging issues right after. Okay, so if anything, I hope this gives folks a good head start. Okay, we're done with the if statements and decisions. Next week is actually going to be kind of important. It's actually one of the biggest takeaways in this class, loops. Right, we'll talk about for loops and while loops. This is probably the part where a lot of people might fall behind because these next 2 weeks are kind of dense in my opinion. Like loops, and then right after that, it's going to be some algorithms. Right, so I highly recommend trying to get back on track if you're like a few weeks behind, because yeah, the loops is when most folks can fall behind. So yeah, please let me know if you need help catching up on anything. Other than that, we are done for today. Have a great day, folks. Thank you all for coming.